So let's look at a one-dimensional motion problem. So I'm going to start with an airplane, and it's going to start from rest, and it needs to reach a velocity of 250 kilometers per hour. And the runway is 1,500 meters. We want to know what acceleration is required, assuming a constant acceleration to achieve takeoff, and what is the time required. So when I'm looking at a problem in physics, some things I want to double check on. I know that I've got it at rest. I've been given another velocity here. That's something else. And I've been given 1,500 meters. And we know we need acceleration. So one of the things that I can do right away is I can put down here that I need to figure out acceleration. I have an initial velocity of 0 meters per second. I have a final velocity of 250 kilometers per hour. So one of the things I know right away is I got a problem. And the problem that I have is I don't have the same units. So I'm going to have to do a conversion, which is one of the reasons I did that, just to refresh ourselves on conversions. So there are 1,000 meters in 1 kilometer. And if you happen to remember it, you can figure out there are 3,600, 1 hour is 3,600 seconds. And you can get that by doing 60 minutes and 60 seconds and get our 3,600. So I'm going to go ahead and do that conversion real quick. So I'm going to start out with everything in meters per second. So I'm going to get my 250 times my 1,000 divided by my 3,600. And I'm going to get 69.4 meters per second. So I have my initial velocity, I have my final velocity. We're also given a distance, and my distance is 1,500 meters. And we have a few things that we have at our disposal. The thing we have at our disposal is our toolkit. So let's look at our toolkit. We have that V final squared is equal to V initial squared plus 2 times my acceleration times my distance. And we may have seen this written in the book like this: V final squared is equal to V initial squared plus 2A times my change in position. This one looks pretty good already because we've got a distance, we have an initial velocity, and we have a final velocity, and we're looking for an acceleration. So I'm probably going to use that, but we also know that I have a time required. So I've got something else that I've got to deal with. I've got a time required. So I'm probably going to need something else as well. So I got V final is equal to V initial plus acceleration times time. And if I know acceleration, this one's going to allow me to find time, so I can use that equation. Or I have my change in position is equal to my initial velocity times time plus 1/2 the acceleration times time squared. So I have a couple of ways of achieving which one I'm going to get time for. But we're going to start with this one, and I'm going to go ahead and solve for acceleration first. So I'm going to have 2AD is equal to V final squared minus V initial squared. My acceleration is going to equal V final squared minus V initial squared divided by 2 times my distance. Let's look at my units. I'm going to have meters squared divided by seconds squared, all divided by meters. One of these meters cancel out, and I end up in meters per second squared. So this tells me, by looking at my unit analysis, that I have done my rearrangement correctly. So I know that I've rearranged what I need to have to be able to get that correct. So now I can plug in numbers. My final is 69.4 meters squared seconds squared minus 0 divided by 2 times 1500 meters. And now I can plug that in my calculator. So I've got that carried, so I'm just going to carry that there. There's my square. And that's going to now be divided by 3,000 because 2 times 1500 is 3,000. And it says that I have to accelerate at 1.6 meters per second squared. Actually, that's 1.61 meters per second squared. So that gives me the distance or the acceleration that I have to have. So now let's go back in here and solve for time. So I'm going to have acceleration times time is going to be my final velocity minus my initial velocity. Time is going to equal the final velocity minus my initial velocity divided by my acceleration, which in this case is 64 or 69.4 meters per second. And now I'm going to divide by 1.61 meters per second squared. That's going to give me seconds. So this is going to work out okay. And so now I'm going to get my 69.4. Try that again. 69.4 divided by 1.61. And that tells me that it'll take 43 seconds for this plane starting from rest to take off on a 1,500 meter runway. Did that make sense to everybody?